In order to minimize incompletely specified state machine, we have some methods. They are called merger chart methods. Merger chart methods. So in merger chart method also we have two more models. One is merger graph, another one is merger table. Okay, merger graph and merger table, these are the two methods we have to minimize incompletely specified state machine. Just now I have explained you what is meant by incompletely specified state machine. You can see here, students, in your for the present states what they have given A, B, C, D, E, F. Some of their when the input is applied for each present states in at some instance, they haven't given you what is their next state and output. So if a information is given incompletely in the state machine, we can call such a type of table or machine as incompletely specified state machine. To minimize completely specified state machines, we have partition technique. Whereas if they give you incomplete information in the state machine, then we have some methods to minimize them are merger chart methods. In merger chart method, either you can use merger graph method or else we can use merger table method. We can use any of the method to minimize incompletely specified state machine here, students. Okay, so let me explain you how to draw this incompletely, how to draw this merger graph. First of all, later we'll see how to minimize using merger table in here. Okay, so let me help you to move to your merger graph method. Okay, students, you can see a graph like structure here. Can you see a graph like structure on the screen?
Yes, sir.
Yeah, this is called merger graph method. Okay, this is called merger graph method. Okay, we need to draw graphs in between each and every vertices or present states what they have given, students, based on their present states, next states, and each and everything in here. Okay, so let me explain you how to do each and everything, students. For that, they have clearly given what are the steps that you have to follow for drawing a merger graph. Let me read the points for to you, then we'll enter into the simplification using this incompletely specified state machine. Let me read this, students. Merger graph is a state reducing tool used to reduce states in the incompletely specified state machine. The merger graph is defined as follows. First one, contains the same number of vertices as the state table contains. Okay, look at here, students. For example, if I'm trying to draw a merger graph for this incompletely specified state machine, how many present states are available here, students? How many present states are available?
6.
6. A, B, C, D, E, and F. So your major graph also should have 6 vertices. Each vertex is representing each present state. For present state A vertex and a vertex. For present state B, a vertex. For present state C, a vertex. Like that, for each present state, we need a vertex. Totally 6 vertex should be taken to represent this incompletely specified state machine for to minimize using merger graph table. That is your first step, student. Okay, you need to select number of vertex that are there in the incompletely specified state machine. Then look at your step number 2. Each compatible state pair is indicated by a line drawing between the two vertices. Okay, each compatible state pair is indicated by a line drawn in between the two states vertices. Okay, vertices. Okay, that is what we have to do. We have to draw the lines. Okay, you can see in the graph also, students, we have drawn some lines in between the vertices from A to C, from A to B, from A to D, like that. We have drawn lines in between the vertices. Okay, so the lines has to be drawn based on the compatible pairs, compatible state pairs. Okay, so how that lines has to be drawn, look at here. I will tell you what is meant by compatible state pair later. Third point, each potentially compatible state pair. Okay, each potentially compatible state pair with outputs not in the conflict, but whose next states are different is connected by a broken line. Okay, every potentially compatible state pair with outputs not in conflict but whose next states are different is connected by a broken line. The implied states are drawn in the line break between the two potentially compatible states. Okay, so let me explain you a compatible state first of all, then we will understand how to draw the lines. And let me go for the last and final step. If two states are incompatible, no connecting lines is drawn in between them. Look at here, students. I will go from back to front, like how we are going to represent, compatible pairs here. Look at, students, from the step number 1, what I told, how many present states are there in the incompletely specified state machine, that many vertices has to be taken. So for state A, a vertex; for state B, another vertex; for state C, another vertex; for state D, another vertex; for state E, another vertex; for state F, another vertex. Like that, 6 vertices has to be taken, students. Then we have to draw lines in between them, okay, based on the compatibility in between two states. Look at here, students, you can see different kind of drawing the lines. You can see A and B are connected with a complete line, or disconnected line, okay, with a continue line from A to B. Since state A and B are compatible states. Why? Because check here. You can see, students, state A and B, you got to check here. When I'm checking state A, when input I1 is applied, what is your indication here? For the present state A, when the input I1 is applied, what is the information they have given here?
Don't care, sir.
Don't care. Means in this don't care, you can have any information. You don't know what is the information available. You can assume any information which is available in there. Okay. Then when I'm applying input I2 for the present state A, I got C, 1. For the present state A, when input I3 is applied, your next state is 1 and output is 1. For the present state A, when input I1 is applied, my next state is B and output is 1 here. Now compare A with B, students. A with B for the different inputs what I am having. Compare the states for the input I1 between A and B. What is happening? Here for A, when input I1 is applied, I have don't care. And for the present state B, when input I1 is applied, I have E, 0. Students, I told you earlier, if you have a don't care in the corresponding box, you can compare both of them like this. If don't care is available, I can assume that E, 0 is available in this information. When the present state A is applied with the input I1, if don't care is available, when I am comparing the states A and B, I can assume that in this don't care, same E, 0 is available. E, 0 is available. Like that, compare A and B for the input I2. What is happening, students? What is there for A when input I2 is applied? Next state
C,
is
comma
C.
one.
C,
Yeah.
And output is 1,
Yeah.
sir.
Next state is C and output is 1. What happens to your B? What happens to your B?
We can assume that
We can assume that
Assume
C,
state is
comma
C and output
yeah,
is
C,
1.
1 is available. And what about your I3? E, 1 is
E,
available
1.
with here, and here it is don't care. So I can assume E, 1 is available.
Assume E, 1.
Then compare A, B for I4. What is available? B, 1 with A and don't care with your B. So I can assume that B, 1 is available. Means your next state is same and your output is also same in between A and B. Is that is true or not, students? When I'm comparing states A and B
Yes,
for
sir.
different inputs, when the don't care is there, you assume that same next state and same output is available. So then when I'm comparing A and B for each and every input, same next state and same output is available. If you find something like that, when you're comparing two present states for the different inputs, if you find same in next state, same output for the input what they have given, same output for the input what they have given, I can tell that these two states are compatible states. What I can call, students, these two present states are
Comparable states.
compatible states. If I want to call two states are compatible, their next state, their output should be always same. Now tell me, students, whether A and B are compatible or not.
Yes,
Yes,
sir.
sir.
Yeah. Now
Sir.
come to the part. Since the state A and B is compatible, I will be connecting vertex A and vertex B with a continuous line. With a continuous line. That is what I have to do, friends. Now, in same way, you need to compare. Okay, in the same way, you need to compare A with C, A with D, A with E, A with F. Each and everything should be compared here, students. Okay, comparison should be done from one state to other state completely. Okay, then you need to compare B with A, B with C, B with D, B with E, and B with F. So we have to check compatibility between each and every state, students. Okay, then after completing vertex B, you need to go for C, and C is to be compared with D, E, and F. After completing C, you have to go for D. D is to be compared with E and F. After completing D, E is to be compared with F. Like that, each and every state is to be compared with all other states which are available for the compatibility. If compatibility is matching, you just draw a straight line, a connecting line in between those two vertexes. And there is second point, students. There is second point in connecting lines. If two states are having same output, if two states are having same output but different next states, look at here. When I'm connecting B and C, what is happening, students? I'm connecting both B and C, but in the middle, I'm writing E and F. Let me explain you why I'm writing EF and here. So what is the vertex in between these two, students? EF is connected in between B and C.
B, C, sir.
Yeah. Now compare B and C. Compare B and C. What is happening, students? Look at the outputs. What it is having? What is the output here?
Zero,
You are having
sir.
0. So
Zero,
same output is available in here. What about the next states?
Next states are different.
Different.
Different,
For
sir.
B
Yeah,
it is C, and for C it is F. Then compare this condition. Compare this condition. It is matching, students. Since I'm having don't care, I can assume F comma 1 is available. Here also don't care, no problem. Here also don't care, no problem. So in one condition, outputs are same, but next states are different. In that case, B and C are compatible. Okay, B and C are compatible with different next states. With different next states. When I compared A and B, their next states, their outputs, all of them are matching. So they are directly compatible. But when I'm comparing B and C, students, what is happening? They're having same output, but different next states. So what I will do? I will connect B and C, but what is it? What difference next states you're having between B and C? What is
E and
it?
F, sir.
EF.
E and F, sir.
So that E and F is written in the middle with a disconnected line. I will write what are the different next states that are available. I will write in the compatibility lines here, students. That is second thing when I'm drawing the lines. There is third thing, that incompatibility. So if I'm comparing the lines, if I find they're having different outputs, directly they are incompatible. Okay, their outputs are not at all same, they're directly incompatible. Let me check here, students. Can I find any line between E and D? Can I find any line between E and
No,
D
sir.
here? No.
No,
Why?
sir.
We'll check here whether they are compatible or not. Okay. So look at here, compare D and D. In I1, I can see same don't care and don't care, no problem. Here also I have same condition, don't care and F comma 0. We can think that F comma 0 is available in here. Check this condition, students. Check this condition. What about the outputs? What about
Output
the
different,
outputs?
sir.
Outputs are
Output is
different.
different,
If you find outputs are different in any input condition, directly we can consider they are not at all compatible. They are not at all compatible. Then you no need to draw any line between those two vertices. You no need to draw any line in between those two vertices. Students, have you note down this table state diagram? Anyone?
Yes, sir.
Yeah, it is completely available with you, Sudeep.
Yeah, yes,
Yes,
sir.
sir.
Yeah, okay. So now I'll explain you how to draw this one completely now. Okay, so I have gone for a reverse engineering because to explain how we have to draw the lines. Now we will go in a procedure how to draw this table first of all. Okay, so let me explain you how to draw this state tables here. Measure chart here. Then if state machine is available with you, it is very simple, students, not a toughest part. Now what is my first step, students? I have to see the incompletely specified state machine, and I have to make vertices first of all. Okay, number of vertices first of all. So how many present states are available, students?
Six,
Six,
sir.
sir.
6. Yeah, 6. So I'm mentioning them: A, B, C, then D, then E, and F. So these are the different present states I'm having mentioned, with each one having a single vertex. Then take your incompletely specified state machine, students. Compare A and B. Tell me whether they are directly compatible, or whether they are compatible with different next states, or whether they are incompatible. Compare A and B, students. There is a condition I told you. If they are compatible, they should have exactly same next state and output. If they are if they are having same output with different next states, they are compatible. But we are connecting those two vertices with discontinued line, mentioning the different next states in between the vertices. If they are not incompatible, they will have different outputs. Now compare A and B and tell me whether A and B is directly compatible or not compatible.
Directly compatible.
So,
Directly compatible.
okay, then students, can I think they are A and B having same next state and same output?
Yes, sir.
Yes,
Yeah,
sir.
then I'm trying to join the lines like this. Next, students, compare A with C now. A with C. Compare A with C. Compare A with C, students. So A is having don't care, C is having F comma 0. Then in I2, input I2 between A and C, output is 1, but a different next state, C
Different
and F is
states,
available. Then if you go for input I3, E1 and don't care is available, no problem. Then when I'm comparing A and C for input I4, B1 and I1 is there, so no problem. They are compatible with the different next state, students. Okay, different next states are available in between them. Then what I can write, students? What I can write? So can I join A and C?
Yes.
How I have
A
to
and
join?
C.
Yes, sir.
Different CF, sir.
C and F, sir.
Different states.
Yeah, I need to mention CF in between them. Okay, CF. Yeah, CF. Okay, students.
Discontinued.
From some students' background, some disturbance is coming. Okay, so someone who is having disturbance, please unmute your voice. Okay, then A is compared with B, A is compared with C. Now you compare A and D. Compare A and D, students. Tell me. Compare A and D. So first one is don't care, second one is don't care, third one having same output, different next states are there. What are the different next states, students?
E and B,
B,
sir.
B, sir.
Okay, what is that? B and E.
E and B, sir.
Okay, so let me write BE in between them. So I'm writing that, students. B and E is written in between them. Now A is compared with D. Now you compare A with E. Compare A with E. Whether they are compatible.
Not compatible, sir.
Not compatible, sir.
Not compatible,
Not
sir.
compatible.
Yeah, let me see this ones. AE having different next states, sorry, different outputs. They are not compatible. There is no issue, students. Okay. Then compare A and F.
Not compatible,
Not
sir.
compatible, sir.
A and F. Okay, don't care.
Not
Don't
compatible.
care. Okay, not compatible. A and F also not compatible. So A is compared with all other higher represent state, students. Now you compare B with C. Okay, A with B is completed, students. So I'm going for B with C. Tell me, students, what is your comparison between B and C? Same outputs, different next states.
Compatible, sir. But
Compatible
different
with
next
different
states, sir.
CF, sir.
So tell me, what are your comparisons here? B is to be compared with C, and with the different next
And
states.
different next states, E and F, sir.
E and F.
ENF.
Okay. EF is written here, students. Now you compare B and D. Compare B and D.
Compatible, sir.
Directly compatible.
Compatible, sir, and different next
Different
states
B
E and
is
B, sir.
Okay. Different next states. What are the different next states you are having, students?
E, sir.
E and B, sir.
BE. BE Nandi?
Yes, sir. Yes, sir. B
Okay.
and D, sir.
Okay, BE is denoted, students. Now compare B with E. Compare B with E.
Compatible, sir.
Compatible, sir.
Directly compatible or next states are there?
Directly compatible, sir.
Direct-
Okay, so I'm connecting BE directly with a straight line. Compare B and F. Compare B and F.
Yes, sir. Compatible, but different next states, sir.
Okay, then what are the next states available?
E, C, sir.
CE. Only one state or two different next states are there? Only one?
Only one, sir. Yes,
Okay,
sir.
what we are comparing B and F. So CE
Yes,
is one
Yeah,
next
sir. B
state.
and F, sir.
Okay, B and F is only the different next state. Okay, so B with F is completed means B is completed, students. Now let us go for C. Compare C with D. Compare C with D, whether they are directly compatible or different next states are there.
Directly compatible, sir.
Directly compatible.
Okay,
sir.
so I'm drawing a straight line. Think this is a straight line, so I cannot draw directly. Then compare C with E. Compare C with E.
Sir, excuse me, sir.
Yeah, tell me.
Sir, B and D are directly compatible, sir.
B and D. Let me check. So B and
Yes,
D
sir.
having don't care, don't care, don't care. Yeah, B and D are directly compatible. Someone
Sir.
told me they're having next states. Okay, so that's why you should be very cautious, students. Okay, so I listen to your thing, then I have drawn. Okay, B and D are directly compatible, I can see. So same next state and same output is also available. So I have drawn a straight line in between them. So CD is completed, students. Check CE. Check CE. So it is compatible.
Directly compatible, sir.
And then we are comparing CE. So what I'm asking you to check. What I'm asking you to check. C and E.
Yes, sir.
CE. Check
Different
here.
outputs are there, sir.
Different outputs are there. Yeah.
Indirectly
So
Yes, sir.
F comma 0 and
Not
this one.
compatible.
Yeah, they are not at all compatible. C
Not
and E are
compatible.
not compatible since they are having different outputs. Okay, C and E is over, students. Compare C and F. C and F. Here it is okay. Here it is okay. Here it is okay. Here it is okay. So C and F are directly compatible, isn't it? Check there. Okay, with the different next states.
Next state, sir. F and C, sir.
Yeah,
Sir,
F and
F and
C.
C.
Okay, students, what condition you got? Check here. A tricky condition. C and F is compatible with different next states. With the different next states. What are the
Yes,
next?
sir.
CF. So when you're getting such a type of condition, you mention it for the first time. Okay. So when you're comparing C and F, okay, so you draw a line, nothing to worry here. Okay, with the different next state CF. CF is compatible with the next state CF you are getting. In such a case, you can directly draw a line in between them, students, actually. Okay, CF is compatible when the next state CF is compatible means you can draw a straight line. But for now, you are doing a first problem. That's why you write the condition. Later we will explain that step later. Okay, C is completed. Let me go for the vertex state D now. So compare D with E. Compare D with E, students.
Yes, sir.
Compare
Compatible
D,
and different next
compatible.
states, sir.
Compatible with different states, sir.
Yeah, what
AB,
are the
sir.
AB are the
AB,
different
sir.
next states available. So in between D and E, you draw a line with the different next states AB, isn't
A
it?
and B, sir.
Yeah. So
Yes, sir.
I'm writing AB here. Okay. So AB in between them. Now DE is
They're
completed,
not
students.
compatible, sir.
Sir, E and D are
And
not compatible,
output,
sir.
sir.
Different outputs, sir.
Different
Check here.
outputs, sir.
Check here, students.
So not
Should be very
compatible,
cautious.
sir.
Check DE. So here it is okay. Then here it is okay. But here 1 and 0 different outputs are there. So D and F are not compatible. D and E also not compatible, students, isn't it? DE is not compatible. DF also not compatible. So there is no need of drawing the lines between DE and DF. Okay, there is no line between DE and there is no line between DF. Both are incompatible. So D is over. Let us go for E. Check E and F. Compare EF. So first condition, no problem. Second condition, no problem.
Different next states,
Yeah,
sir.
how many next states are there? Here you are having peculiar condition again.
Two,
So
sir.
two different next states are
sir.
there. Two different next states in
A,
between E
B,
and F.
C, D.
So two different next states, A, B and
C, D.
C, D. So two different next states are there
C.
in between them. So this is your first step, students. This is your first step in merger graph. Okay, in merger graph, what I have to do? I have to take what number of vertices, how many I need for representing each present state. Since in the given incompletely specified state machine, I have 6 states. Okay, 6 states. Okay, so for drawing, for mentioning each state A, B, C, D, E, and F, I have taken vertex and I compare each state with other state and have checked whether they are directly compatible or they are compatible with different next states or they are incompatible. I have checked the 3 conditions. I have drawn a primary or primary merger graph. I have drawn in here. Now, what is my next step? Look at here, students. When I'm calling a direct line, connecting line between AB is directly a compatible pair, students. There is no problem at all. AB can be directly taken as a compatible pair in here. But when I come to the next condition, AC, I have connected AC, but I have mentioned they are having different next states in between A and C, means that if A and C wants to be compatible, their C and F also should be compatible. That is a condition. If I have direct line in between 2 vertices, they are directly compatible, not at all a problem. Then when I'm drawing a discontinued line in between 2 vertices like A and C with the different next states, if A and C wants to be compatible, then their next state CF also should be compatible. If CF is compatible, then only your AC will be compatible. Check here, students, whether CF is compatible or not. Check, students, whether CF is compatible or not. So check, this is C and this is F. CF is connected. Okay, CF is connected here, but with a different next state CF. If you get a tricky condition like this, CF is compatible only when CF is compatible, you no need to worry. You can directly draw a line in between them. Okay, CF is compatible with the different next state CF, then they are directly compatible. Students, do you understand what I'm saying? If CF is compatible, if
Yes,
CF
sir.
wants to be compatible with different next state CF, we directly can consider a direct line in between C and F. So can I say CF is compatible now, students?
Yes, sir.
Then you have a tick in here. Then you compare AC is completed, you compare AD. If AD wants to be compatible, what should be compatible?
BA, sir.
B and
B. Check whether
should
B
be
is directly
compatible.
compatible. Check whether B is directly
sir.
compatible.
Yes,
Yes.
sir.
So you give a check mark. If B is compatible, you can directly take AD also compatible, students. Okay. So your AD is also over. Then you check AE, there is no line. Don't worry. AF, no line. Don't worry.
Incompatible.
Yeah. Then you go for the next vertex B. BC, if BC wants to be compatible, okay, if BC wants to be compatible, your EF also should be compatible. If BC wants to be compatible, EF also compatible. Check whether EF is compatible.
No, sir.
No, you should not say like that, students. You should not say.
ABC.